Here's the solution for day 4. Use a calculator to graph this equation. Use the following window settings and then accurately draw what you see on your calculator screen into this rectangle. So this is something that you're going to be asked to do a lot this year because part of pre-calculus is to learn how to use a TI-84 calculator. And so for me to know if you know how to use the calculator, I need to have you show that in BellWorks and on quizzes. So I have my calculator on the screen. It looks just like yours. I'm going to turn it on and then press the Y equals key. Now I have an expression already in there. I want to clear that, so I'm going to press clear. Now here's where I want to type in x cubed plus 2. So I push x, then the exponent key, which is on the right side, this little up arrow key, and then to the third power. To hop back down with the cursor, I push the right arrow, and then plus 2. So at this point in time in the calculator, I've got y1 equals x cubed plus 2. This equation matches this one here that we're asked to figure out. The next thing I want to do is I want to change the window settings to correspond to the directions here on the left side of the screen. So push window. And there's all kind of numbers already in here, but I want to replace these numbers with what I'm told to use. So for x minimum, -5, down arrow. For x max, 5, down arrow. I want x scale to be 1, down arrow. Y minimum, -10, down arrow. Y maximum, 10, down arrow. Y scale 1, and then x resolution 1, and those are already correct. So now that I have my equation typed in the y equals screen, and I have my window corresponding to the directions given to me, I'm going to push graph. And here on the screen, it draws a picture of the graph. So the next thing I need to do is, to the best of my artistic ability, copy what's on my calculator window into this rectangle box. The unfortunate thing as I'm recording this video is I can't have this calculator emulator on screen at the same time that I'm drawing into my OneNote program. So for me to draw into this window, I have to take this calculator off of the screen. The y-axis runs straight down vertically down the middle of the window. The x-axis runs straight across horizontally, right across the middle. On the x-axis, there are 5 marks where the 5th mark is right at the edge. So I want to try to space that out as best I can. 1, 2, 3, 4, 5. That's pretty close to what that calculator looked like. The same going to the left. Try to keep the spacing equal on these x-axis marks. Now on the y-axis, there were actually 10 marks from the origin on up. So it's going to be a lot closer together marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. On my calculator screen, this 10th mark is actually right along the edge of the rectangle. I have a little bit of space in there, but that's pretty close. Now I want to show that curve that was on my screen, but I want to show it accurately. Let me slide the calculator back into view again. I want to get that curve accurately onto my paper. Pay special attention to intercepts. For instance, it intersects the x-axis just a little bit to the left of the -1 mark, and it crosses the y-axis, it looks like, right through the 2. When we draw, we want to make sure we're doing that accurately. The other thing that you can do to make a very accurate graph is you can look at the table of values and then plot those dots. To do that, you push the second key and then table. My table happens to start with x is 0, but if I use the up arrow, I can get some negative x values. So now I can more accurately graph. For instance, there'll be a dot at -2, -6. There will be a dot at -1, 1, a dot at 0, 2, and so on. So let me slide the calculator off the screen so that I can actually graph those dots. Let's find -2, -6. 1, 2, 3, 4, 5, 6. It's right here. Another dot was -1, +1, which is right here. Then 0, 2, right there. That one's called the y-intercept. Then 1, 3, then 2, 10. The next one was 3, 29. That's going to be off the top of the window. Remember that this was a curve through these dots. So it went up like this, started to bend, went through this dot, and then swung up again and went up off the top of the screen. Let me drag my calculator back onto the screen so you can compare my drawing to what the screen of the calculator shows. It's pretty good, isn't it?